Today, we're going to derive the formulas for 6 trig identities. We're going to find the formula for the sine of x plus y, the cosine of x plus y, as well as the sine of x minus y, and the cosine of x minus y. And I guess the same too for the tangent functions. Now, these proofs, they're going to be mostly geometric proofs. So what we want to do is we want to have a triangle, a right triangle that has angle x. And we also want to have a right triangle that has angle y. So suppose y is this size. Let me just make it a little bit. Hey, I can make this as long as I want, and it doesn't do anything. But I want a right triangle that has angle y. The angle y is made up of these two rays. At this point right here, I'm going to go at a right angle. So this angle is right all the way up to there. And that's going to be angle y. I can talk about trig functions with respect to angle x because I have a right triangle, and I can talk about trig functions for the angle y because I have a right triangle. But right now I can't talk about anything with respect to x plus y. So through this point right here, I am going to draw perpendicular. So hopefully now you can see a triangle that has a right triangle for angle x plus y. It goes from A to B. Let me just label this E. So it goes ABE. Triangle ABE. It has an angle. It has this as one of its angles. Make sure you see that, please. Okay. Now, I know that. So now I just want to say one thing first. I can scale this diagram and make it bigger or make it smaller. The size is up to me. Well, I want to scale it so that AB, the length of AB, is 1. So now, when it comes to the sine of x plus y, again, here is the triangle ABE, and the sine of x plus y is going to be the opposite, which is BE, divided by 1, which is BE. Now, the thing is that I know what the formula is. The formula has to be a sum. It is somehow, BE, not B plus C. I'm thinking sum already. Somehow, I need to break up BE into a sum. And that's where you have to say, you know what? Let us draw from point B, not P. Let us draw a line from point B parallel to BC. Right there. So this is a right angle, and ABC, this is point F. Now, I claim, and I'm going to prove it, that this angle right up here is angle X. Now, let us look at this triangle at their top right. FBE. No, I'm mistaken. I am mistaken. Let us call this point here G. Let us look at the triangle EGD. EGD. Okay. Let us look at that triangle. Now, here is a right angle. Okay? Now, whatever angle we have here is going to be that same angle there, angle 1. Now, let's look at this bottom left triangle, ABG. Let us just look at this triangle. Since it has a right angle, the other two angles, angle X and angle 1, they must sum to 90 degrees. Okay, but if we look at this triangle, it has a 90-degree angle, so this angle and this angle must sum to 90 degrees. But this is angle 1. We know what to add to angle 1 to get 90. X. There's only one number you can add to an angle so it adds up to 90. In this case, to angle 1 you add X. And that is why I get to call that angle X. Okay, so we have that as X. Now, BE. BE is this long length right here. Okay, well I can break it up into a sum. I can say it's BF plus FE. It's BF plus FE. But you know what? BF is the same length as BC. So I can call this BC. Now, let us find out how to write BC in terms of trig functions, etc. Now, if we look at this big triangle here, this triangle right here, we know that the sine of x is the opposite BC, that's why I picked it, over AD. Bringing this up here, we know that AD sine x is BC. Okay, so the sine of x plus y is this, which is AD sine x plus FC. Well, what triangle has, so FC, FE, it's BF, BE, this whole length, it was BF plus FE. So that should be FE. And instead of FB, or instead of BF, we use DC. Sorry. So now, FE. Where is FE? Well, FE is right here. And the only right triangle it's in is this one. And there's the right angle. And with respect to angle X, which is right there, you know that the cosine of X is adjacent FE divided by ED, the hypotenuse. That is, ED cosine of X is FE. Okay, plus ED cosine X. So we're halfway done. But we're through the hard part. Now we really know what we want to find. We want to find AD. Well, AD is this blue side right here. Now, if you look at the cosine of y, the AD is the adjacent, but the hypotenuse is 1. That is, AD is cosine of y. Okay, cosine of y sine x plus something times cosine x, namely ED. Okay, so now I look for ED. ED is right up here. You know what? The sine of y, the sine of this angle, is the opposite ED or DE over 1. That is, the sine of y is ED, the sine of y. And just permuting multiplication, I now have that sine of x plus y is equal to that. That's exactly what we want. Just so I can have this area to do the cosine of x plus y, we can just bring our formula down. That should give us enough room. And then we look at the cosine of x plus y. Well, x plus y, as always, is ABE, triangle ABE. And the cosine is AB divided by 1, the hypotenuse. Okay, so it's just AB. And we have the knowledge that the cosine is going to have a minus in the middle. That is, I want to write AB as a subtraction. That would really be helpful if I can write AB as a subtraction. And it's kind of obvious. Go out to AC and then take away BC. But you know what? BC, in case I need it, BC is the same as this piece up here, as DF. So now, it'd be really nice if I can write AC in terms of, angle X or Y. Now, AC is this whole piece. And we have this big triangle. And AC, well, if you take the cosine of x, you get AC divided by the AC divided by the hypotenuse. That is, AC is AD cosine x. AD cosine x. And while we're at it, let's find out what AD is. I think we already had that. If you look at the cosine of y, it's AD over 1. Look at this top triangle, this one, including this. Let me show it. This top triangle. ADE back to A. Cosine of y is just AD. So we have cosine y, cosine x minus. Now, BC, this length right here, is not part of any right triangle. That is why here I'm going to use DF. And DF is in this blue triangle. Right there. DEF. Here is the right angle. Now, DF is the opposite of x. The sine of x is equal to DF over the hypotenuse, which is DE. That is DE sine F, sine X is DF. So we have minus DE sine x. But what is dE equal to? Well, dE is this part right here. Let's just use the big triangle that has angle y. And you discover that the sine of y is dE over 1, or dE. So you have the sine of y. The sine of y, sine x. That is, I like the formula, we had x's first. Sine x, sine y. And that's exactly what we set out to prove. And now we're going to prove with these formulas. Let me erase all of this. We're now going to prove the other two that I talked about next. We're going to derive the formula for the sine of x minus y and the formula for cosine x minus y. And it is not going to be geometric. Since we only know a rule for a sum of two angles, you just have to realize that you can always go from subtraction to addition, or addition to subtraction, or multiplication to division. You have a division rule. If you have a multiplication rule, you can always go from division to multiplication. Here, there's a real simple rule. First of all, that y is understood to be positive y. There's a rule that says we can change both of those terms. So this becomes x plus minus y. And now I have a sum. And I use my sum rule. X is the first angle and negative y is the second angle. So it's, and you know, that's the first, that's the second. It's the sine of the first, which happens to be x, times the cosine of the second, which is y, plus the sine of the second times the cosine of the first angle. Now, the cosine of negative y is cosine of y. And the sine of negative y is minus the sine of y. That's why I wrote minus. And there's your formula for the sine of x plus y. Sorry, the sine of x minus y. Same game with cosine. Think of the angle as x plus negative y. And then you just use the rule. It's the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. And then we're 90% done. You get the cosine of x. The cosine of a negative angle is just cosine of the angle. That minus comes in front. That's minus sine of x times the sine of y. And there it is. This equals that. All it is just rewriting x minus y as x plus negative 1. Can always change, say, subtraction to or addition to subtraction. For example, if we derive this rule using some other method, now I can say the cosine of x plus y is equal to the cosine of x minus negative y. I can use this rule. I can use that rule because I only know a rule for subtraction. And then I will get the rule for addition. That completes this video for sines and cosines. Let's look at tangents. What is the, so let me erase this. What is the tangent of x plus y? Now, we possibly could go back to that diagram or maybe draw another diagram and prove it. But we have it in front of us. The tan of any angle is the sine of that angle divided by the cosine of the same angle. Well, the sine of x plus y, that's in front of us. It's the sine of x times the cosine of y plus the sine of y times the cosine of x all over the cosine of x times the cosine of y minus sine x cosine y. Sine y. Okay. So now I want to divide each and every term by sine, cosine x, cosine y. So I'm going to take this term, I'm going to divide it by cosine x, cosine y. I'm going to take the next term, sine y, cosine x, and I'm going to divide it by cosine x, cosine y, all over cosine x, cosine y over cosine x, cosine y, minus this piece, sine x, sine y over cosine x, cosine y. And let's see what we get. Well, we get a division. So what does this piece become? Well, pretty clear that the cosine y's cancel out, and you're left with that, which is tangent x. Tangent x plus. Here, you have cosine x's canceling out. So you're left with sine y over cosine y. Why? That's tangent y. This, I hope you realize, is 1 minus tangent y, sorry, tangent x times tangent y. Tangent x, tangent x, tangent y. There is the double angle formula for tangent of x plus y. The tangent of x plus y. So what we just discovered was the tangent of x plus y equals that. Armed with that, you can find the tangent of x minus y. In fact, let's do it. The tangent of x minus y. Now we only have a formula for sum. Alright, so write it as a sum. And everything will follow. You get this is going to equal to the tangent of the first angle plus the tangent of the second angle divided by 1 minus the tangent of the first angle times the tangent of the second angle. So we have tan x. Now, the tangent curve is an odd function. That is, that comes out as minus tangent of y. 1 minus, this comes out, oops, way out in front and makes that a plus tangent x, tangent y. So the tangent of x minus y is simply that. Okay, that concludes this video.